Hello Tech Time Travelers. Today we're beginning a special project to restore a very vintage, very rare all TTL terminal from around 1974. This unit has been my digital Schrodinger's cat, in that as long as I didn't power it up, I couldn't say for sure it wasn't working. But I decided it was time to do something with it after watching it sit there on a shelf forlornly for several years with a broken bottom, a victim of age and FedEx's not so nimble fingers. I suppose I should open this with a little primer on what terminals are, because from past comments on my videos, I've begun to realize that not everyone knows or understands what a terminal exactly is, or how it differs from a computer, and that's probably because a lot of people are too young to have ever really encountered one. Pretty much from the invention of the first computer, there needed to be a way for humans to interface with it, to input data, do stuff with it, and get results. With the earliest computers, you might have programmed the thing switchboard style by literally removing and plugging in different wires to different ports. Some early computers actually had something resembling a terminal for I/O. The German Z3, developed in 1941, had a primitive terminal of sorts. Later, computers developed the front panel as an interface. I demonstrated a mini version of that recently with my video about the Cosmac microtutor. One popular means of data entry was the punched card. These dated back to the 19th century and were used for quick tabulation of data, which made them ideal for entering large quantities of data to computers. A user punched data or programs onto a card, and the cards were then quickly read by an electromechanical reader. Data could then be output on a printer. Another interface, or terminal type that became popular, was the teleprinter or teletype, another device that predated computers by several decades. These machines were basically electromechanical typewriters that converted electrical signals into binary patterns, which in turn became numbers and letters printed on a page. These signals could be sent over copper wires to locations far away, meaning you could interface with a computer that wasn't even in the same town that you were in. Bill Gates famously used one of these along with Paul Allen at their school to program their first product, a version of BASIC for the Altair 8800. However, the problem with teletypes and punched card machines was that they were loud and required extensive maintenance and used reams of paper. This became a particularly acute problem with punched cards, which by the late 1960s had become so numerous, thanks to the sheer volume of data being entered, that whole floors of office buildings or warehouses had to be used to store them. This created an opening for scientists like Dr. Mears Cutt up here in Canada to come up with solutions. What he helped develop, part of a system called KeyEdit and sold by Consolidated Computers, were among the first modern terminals that eschewed the use of paper in favor of a CRT screen. This terminal effectively duplicated the process of card punching that staff were used to, but eliminated the physical cards. Terminals started out quote-unquote dumb, initially being limited to just relaying characters back and forth between computer and operator. But as the 1970s dawned, they started getting kind of smart, able to do things like offline editing or even limited programming. Some terminals are pretty much microcomputers in their own right, like this Hazeltine 1510, which features an Intel 8080 CPU and can function as a standalone computer with some modifications to its firmware. The first micro or personal computers did often use terminals to interface with their machines, like the Mark 8, the Altair 8800, and so on. Creating an inexpensive terminal for home use was one of the driving forces behind Don Lancaster's TV typewriter, the term TV typewriter becoming synonymous with personal terminal. For myself, growing up in the 1980s during the modern microcomputer revolution, with 8-bit personal computers that had their own keyboards and video output, I personally had very little experience with terminals. Examples that I can think of are the cataloging system at our local library, or a video text-based system called Teleguide, which was used to provide a digital mall directory at Oakville Place Mall, or occasionally messing around with someone's terminal at my dad's office. But for the most part, I had no need for a terminal since personal computers were quickly becoming ubiquitous. Terminals aren't completely gone, of course. You could consider this HP Thin client to be a terminal, and you could emulate a terminal on your computer via client programs like PuTTY. But most of us these days have our own computer and thus have little need for an actual terminal. Nonetheless, I find terminals fascinating. They provide a window into a way of doing things that has largely ceased to exist for a lot of users. Whenever I look at an old terminal like this ADM1, my first thought is, who used it? What were they doing every day? What was the last day of work for this machine, and what was it replaced with? Some of the designs that were in use back then were quite wild, like this Honeywell terminal which was designed for airline use, with the teletype style keyboard that some eBay sellers split apart to make some more money. I get a little emotional sometimes about that one. Or how about this Sanders 720, which is so perfectly 1960s with its odd-looking CRT and angular case? Or these IBM terminals that sadly are being tossed aside as people scoop up their highly desirable beam spring keyboards, which really makes me, nope, I told my therapist I'm not going to talk about that anymore. Where's Superman when you need him?
Effective immediately, I'm going to rid our planet of mechanical keyboard collecting.
Anyway, when I discovered this unit we're now about to try some cosmetic restoration on, I had to have it. This terminal, made by an unnamed manufacturer, is a rare surviving example of an all TTL based terminal. There is no microprocessor in this thing. Its brain is just acres of ICs, and I do mean acres. A whole board of them plus 3 add-on boards, including some shiny gold ceramic ICs. Oh yeah, gotta have that. Unfortunately, as mentioned, it suffered some shipping damage. That's the main thing I want to try to address in this video. I kept the pieces and I want to see how well I can reform the smashed bottom of the case and then maybe try powering it up if we dare. So first off, let's do some introductions. I'd love to tell you who made this thing, but I've really no clue at all. There doesn't seem to be any stickers or any hints whatsoever as to who made it. While investigating the innards, I did find that the CRT had a Conrack sticker on it. And Conrack did make computer terminals, but they also just sold CRTs separately for various uses, so it's probably more likely that whoever built this thing simply purchased a Conrack monitor. Speaking of the monitor, one of the things that attracted me to this machine was the apparently wide aspect ratio looking monitor. There was such a thing as wide aspect ratio CRTs. I have a Moro MD3P computer that has such a thing. They're pretty cool and unusual looking. The keyboard I'm pretty sure is a microswitch unit of some description, and it looks like it's had some key top replacements, although why so many I'm not sure. I note the absence of any specially marked keys like you commonly see on a terminal, like bell or operator or stuff like that. Again, this is playing into my belief that someone kind of slapped this together to test out a concept instead of running out thousands of them on an assembly line. This is further reinforced by the fact that we can't see any kind of fancy bezel hiding the motherboard. It's just kind of open here, and this is what I think points to this machine being something experimental, prototypical, or such. Production terminals, even of this vintage, typically had a closed back panel. You wouldn't want idiots sticking stuff in there. I note there's a DB25 here, and that's a hint that this terminal is even a little more unique than the rest. A lot of the terminals of this vintage were designed to be used with specific systems and had very specific interfaces. This terminal may have had serial I/O, which would allow it to interface with virtually any machine with serial capability. And if by chance I can get it working, the possibility of playing Zork or what have you on a 1974 terminal? Oh man. It's really too bad about the shipping damage. Whole chunks of the case have been broken off. This is one of the challenges of buying things online. You can't really know what something is made of. I assume this terminal was built of sturdy ABS plastic or metal, but apparently I should have urged the seller to pack this thing to the extreme. Now with the lid off, let's take a look at the goodies inside. Oh my goodness, so many ICs. Oh, yeah, without a microprocessor, this is the kind of thing you had to do. I can't imagine designing something like this. I get secondhand PTSD thinking about just trying to fix it. I do appreciate how neatly laid out it is, though. I did take a pretty careful look around for markings that might tell us who the manufacturer was, but yeah, they seem to prefer to remain anonymous. But it's not just the motherboard here that's jam-packed with TTL. Check out this card cage off to the side. There's 3 more cards here packed with chips. Crazy. So the screen is really interesting. The CRT itself is not, in fact, a widescreen like the one on my Moro machine. This is a regular 4:3 aspect ratio screen, and they've essentially sunk half of it below the keyboard, which results in it kind of mimicking a widescreen. Why would they do this? Well, I talked to some guys on various forums about it, and they thought it might be just because of limited screen memory. Looking at the IC date codes on this thing, it suggests that this terminal was built in either late 1973 or early 1974. At that time, RAM was incredibly expensive, so the builder of this machine probably decided to just hide the unusable other half of the screen. There doesn't seem to be much sign of burn-in on the CRT, so that has me thinking this thing wasn't used much. Over here is the massive power supply. This thing is kinda intimidating looking. Remember in my keyboards video where I said my Univax keyboard key switches reminded me of the Titanic steam engines? This power supply really reminds me of those engines. Yeah, this is kinda elegant looking, just like that grand old ship. Yeah, it's too bad about the FedExberg. I love shipping something with FedEx and getting a free 3D puzzle. Thanks, guys. Look at this fan that looks kind of like a jet engine strapped atop a capacitor underneath. It actually appears to blow air through an almost triangular shaped heatsink to which multiple power regulators are attached. That's kind of a cool design in my book. I think this board is where various voltages are tuned a bit. Eesh, yeah, lots going on here. Okay, maybe I'm being a tad unfair to our frenemies, the courier company. Take a look at the material these broken pieces are made from. See how it kind of looks like the inside of a crunchy bar? Yeah, this is not ABS plastic or steel. It looks to me like some kind of urethane. In fact, I think this is the same stuff that the very first few hundred Apple IIs were made of before Apple realized that urethane could melt and warp with exposure to heat. 50-year-old plastic would have had a hard enough time standing up to being jostled around, but this stuff? Not a chance. I'm lucky it didn't arrive in thousands of pieces. I also note that it's reactive. The rubber feet on the Netronics Explorer board I had sitting on top of it for a while apparently melted into it. Whoops. The fact that this material was used again hints to this machine being produced in very small quantities. Best guesses? I'm thinking it must have been a prototype or pilot run of a few units, with the intent of producing more if the design worked. Yeah, it's really too bad about the damage to the case. I hate when I buy something that's pretty much all there and then this happens. But I have no choice, this stuff doesn't turn up in my neck of the woods. It's always coming from somewhere far away, so shipping is not optional. Putting this thing together will be a challenge for sure. Apart from choosing the right method and materials, there's the fact that there are some seriously small bits here. Thankfully, the side that broke off is still mostly in one piece, so I should be able to eliminate the big holes. Man, just look at all this TTL. Ooh, what's this? A Fairchild 3258 ADC. Nice white ceramic with gold cap. Yeah, this appears to be a character generator. Here's the datasheet. Yep, this is where the magic happens. We can get an idea of what the text should look like a few pages in here. Actually, we don't even need to imagine at all. The same character generator was used in my MicroKit 816, which I showed off a really long time ago. That machine didn't do much because of the missing software, but it did produce a readable display at least. So let's start disassembling here and see what we've got. The CRT hood comes off in one piece. I previously disconnected the edge connector that came up from the motherboard. That may have been a mistake because the edge connector isn't obviously marked or keyed as to orientation, so yeah, that might be a little bit of fun putting back. Thankfully, I have one photo where I managed to get a picture of the connector while it was still connected. Just a very thin strip of it, so hopefully I can align it correctly. And who even knows if that was the correct way originally. With the keyboard out of the way, we can have a look at what's inside this card cage. The cards themselves resemble S100 cards, but I'm betting they're not, although they do appear to have 100 pins. The first one here says block transfer baud rate. If I understand correctly, block transfer refers to a mode terminals could operate in where you could type in stuff offline or pull it in from paper tape or something and then transmit the whole lot as a block to whatever system you were connected to. That might be what this board does, along with controlling baud rate. The next card says split mode option. It has a part number, but sadly says nothing about the manufacturer, and Google didn't turn anything up. If I had to guess, maybe this gave the terminal the ability to split, or in our parlance, multi-window the screen, so that you could have two different things going on at the same time. That would be kind of weird given how small the screen area is, but you never know. You might see whatever was local on the terminal on one part of the screen, and then on the other, whatever it was connected to. Comments are welcome on this. Now this board, wow, look at the bodging going on. It's hard to say if this is evidence of a design that wasn't fully dialed in yet, or if they were being produced in a low volume. Early 70s, it could be either. The wires aren't strapped down or super neat, so I don't think this was being mass produced like this. Based on the presence of these Intel 1402 shift register chips, I'm thinking this may have been a memory board. What's interesting is in addition to the plastic encapsulated Intel chips, they also have some Microsystems International second source 1402s in white ceramic. So they're kind of picking from different parts bins here. Microsystems International was kind of a public-private, not quite partnership in which the federal government of Canada essentially nudged phone equipment maker Northern Electric, later Northern Telecom and then Nortel Networks, into creating a new company, Microsystems International, to produce semiconductors and other devices. As often happens with these things, Microsystems ran into financial trouble almost immediately, and Northern Electric ultimately folded it into itself. The chip foundry the company created was in use right up until Nortel Networks' untimely demise in 2009. Oh, Canada. Yeah, this motherboard is a thing of beauty, man. I love a well-organized early to mid-1970s no-solder mask board. Of course, the odds of this thing actually working are probably pretty low. You'd have to expect that given so many integrated circuits, 1 or 2 or 3 or 50 are bound to have problems. But you never know. My experience with vintage computers has really surprised me sometimes. You go in thinking no way will that work, and then it just fires right up. ICs are incredibly durable. That said, if it isn't working, I think we're SOL. Without a schematic or an electronics engineering degree, I have no chance of fixing this. Okay, so repairing the physical body of the thing I think should be fairly straightforward. Despite my less than stellar experience with Gorilla Glue while repairing my Sanyo MBC16, I think this is probably what I want for the job. The reason is that it expands a little bit like gap filler, and the final dried product is very similar in texture to this urethane. I have to be careful because I don't want anything that'll melt or damage the urethane case. I've had experienced repair people in my comments on other videos suggest stuff like baking soda and glue, but I think that applies more to ABS plastic than urethane. Bear in mind, before we begin, I am not a master restorer of vintage tech. This is a bit of a learning exercise, so be gentle with those critiques, please. Now, obviously we've lost some tiny pieces here and have lots of cracks and divots. That's okay, I have a plan for that too, my good old friend Bondo. James Bondo. Figuring out how things fit is a challenge sometimes. The smaller the pieces, the bigger the challenge. But it's not too long before I'm getting the hang of it. My biggest problem is just figuring out how to hold it all together while the glue dries. So I settle on using some large mini scribe hard drives, bricks, I can't tell, like so. To attach the biggest broken piece from the side, I employ a mini scribe RAID setup. See? Mini scribe drives were good for something. So now we've got the side reattached, and for some reason I opted to use packing tape to help hold the corner together. The masonry seems to be providing appropriate support. Now to fix this broken corner. So many bits to choose from. The next day I'm able to pull the bricks away and the side definitely seems to be holding. It's so nice to not see a giant hole there anymore. The hardest part I think is going to be this corner. It's kind of a complex fracture. There's a little recessed shelf along the inside which provides support for the keyboard. Bits of that are missing, so this is where my Bondo skills will be put to the test. For now, I'll just focus on trying to find the right pieces to fit the right places. I never noticed before, but apparently a chunk of the screen casing was missing also, so we'll just fix that while we're here. Man, that's a lot of crack. No, not that kind of crack. No, not that kind of crack either. The glue expanded out of the cracks as I expected. I'm just going to remove the excess and hope my Bondo skills smooth all this out. Man, that is one gnarly corner. While I wait for the Bondo to Bondo, I'm going to do some keyboard cleanup. This thing is pretty dirty, but considering how old it is, it's actually not that bad. This is a microswitch unit very similar to others I showed in a recent video about keyboards. If you haven't seen that one, definitely check it out. The PCB is just a little bit different. I start by pulling the keytops carefully. They're stuck on there pretty good, but eventually let go. Now I've got access to the key stems and actual switches, and I'm going to address those with some toothbrush action. I figure since I got it here, I might as well do some resistance testing to see if the key switches still work properly, and also learn a bit more about how they work. If they don't work, there's some potential to borrow spares from my other keyboards, like those decision data units I have kicking around. But they do seem to be working alright if I press the keyboard down hard enough. I'm using nothing more than a damp microfiber cloth here to really scrub the dirt off the keytops, and then return them carefully to the keyboard. Yeah, it's really strange that so many seem to be replacements. That's another thing I could potentially borrow from another parts keyboard. The spacebar is the trickiest thing to get plugged in there. Yeah, now that looks nice. Ready for action. I'll also give the bezel a good cleaning. Why not? Another thing I forgot about, the plug at the end of the power cord was removed at some point, so I'm hoping that wasn't a warning against plugging this thing in. I'll swap a new end on here and pray. These plugs are a challenge and require some dexterity to connect. I always find myself paranoidically checking the wires over and over and over again to make sure that I don't have hot and neutral touching or reversed. The next thing I'm trying to do with my multimeter here is figure out which wires on this motherboard power connector are for which voltage rails by tracing things between known power pins on the ICs back to the power supply. This will hopefully aid me in determining if the power supply is putting out appropriate voltages, which will in turn determine whether I feel safe enough to try plugging in the motherboard. Now, for some reason, this machine has got me really freaked out about the potential for fire. No idea why, it seems to be cosmetically in great condition. I've done my best to sniff around the power supply for any potential shorts. To make matters worse, my cheapo Variac has died, so I have to kind of plug and pray if I'm going to do this. And that's what I decided to do on my testing range outside, aka my backyard, with lots of dry grass. Yeah, I'm a little dumb sometimes. Anyway, it's far from my house, which is what I want, and I have fire control right here. Now note, I've got the motherboard completely disconnected. I just want to see if the power supply will start. Anyway, here we go. 3, 2, 1. Well, that was anticlimactic. The fan turns, but it's nowhere near as powerful as I was expecting. It's actually very sedate. Now that I'm feeling brave, I've powered up the power supply and I'm testing the output voltages to see if they look sane. I do manage to find some that make sense, like there's plus 5 volts here, minus 16 volts could be legitimate if it's being regulated down to minus 12 or something. There's also plus 16 volts on another pin. But some pins don't have any voltage at all, and that's got me worried something in the power supply is dead. Anyway, putting that aside for a moment, back to fixing the chassis. I've selected a Bondo variant that I think will work decently for my purposes. Now, here's my janky looking Bondo job on the corner. It cracked a bit while drying, probably due to the amount I used and the complex shape of the corner. But I sand it down and eventually it starts looking more or less on spec. I'm finding my skills at railroad modeling are helping me a lot, especially with recreating the little shelf for the keyboard. After some sanding, it's really not looking that bad. It just needs a little paint, which I'm going to have a think about so as not to damage the remaining original case. Well, I'm going to remove the motherboard completely just to keep that safe. Yep, just a little bit of bodging on the motherboard. With the board out, I can recheck and confirm some of the voltage rails and see how that lines up with the power supply. And that's when I discover a tantalum cap that has a leg broken at one end. I'm going to order a replacement part for it, but for now I actually think I can reattach the broken leg pieces with some solder. Okay, yeah, it seems to be charging okay for now. Here's a closer look at the voltage regulators with the tunnel hood removed. Some are a little rusty, but testing doesn't reveal any shorts. Back to the power supply, I discovered one of the voltage adjustment potentiometers had some cold solder joints, so I fixed that up. And then back to the testing range to see what results we get. Slightly better, but I still have some weird or wrong or missing voltages, like minus 2.5. Yeah, I'm thinking that's not likely right. So I decide to pull the little board that I think fine-tunes the output, and that's when I discover a couple of potentiometers that are actually broken. So that might explain why I have low or no voltage at all at certain pins. I'll have to order replacements for these once I figure out what the values are that they're set to. Figuring out what they're set to will be important to my chances of getting this whole thing working. Anyway, that's where I'm going to stop for now. Once I get the replacement potentiometers in and can retest the power supply, I'll know if I feel more confident about actually powering the terminal itself up. By all means, if you have suggestions or thoughts or polite, and I emphasize polite, criticism, feel free to leave those in the comments. Since it's summer holiday time, Spaced Squirrel will be delivering the obligatory like and subscribe beg message from balmy EPROM Island, a popular tech time traveler vacation destination, which is just one of many things we spend our patron dollars on. Thanks so much for watching, and we'll see you again soonish.
Space Squirrel here. Just on a vacation at EPROM Island. Ow. If you've enjoyed this, thing, just, like and subscribe, or something. Space Squirrel erased.